Okay, so ideally when you come in here, you can just grab one of these. So go ahead and start working on this program that says do now. It should be some math that you are all familiar with. But I just want to make sure that you guys are comfortable with this before we get moving on. Here. It's like a multiplication. Good question. That X in the middle there just means
X
multiply.
multiply.
Yeah, it's just multiply.
Going back.
Okay. What are you doing here? Show me how you got that. Good time.
I just put it over one to the W fraction. So this is the 2 times 7 is 2.
No, you're going to simplify the denominator.
Just do not.
Just multiply. There it is. That's right. Whoa.
Oh, so you do need to get common denominator.
All of that is, everything you're doing is perfect. This is good. You don't need to apologize. You're doing just fine. You know what? I see that there's some struggles going on here. So I don't want to take a look at this because this is something that we need to have down before we can move on. Okay. Daniel, how do we go about tackling something like this?
Do we need common denominators?
What do you guys think? Do we need common denominator or multiplying fractions?
I don't think so.
I hear yes, I hear and I don't think so.
Not for multiplication.
Not for
Okay,
multiplication.
that's what I thought. Okay. So what I would do, I would just cross multiply. So do the 2 times 5 is 10.
Okay.
And 4 times 3 is 12.
Okay,
I don't know where to go from there.
I see what's going on there. Does anyone else have another idea?
That's for division, the cross multiply, I think, but the multiplication is just straightforward.
Okay. So, so Sai's telling us that when we're multiplying fractions, we're just multiplying straight across. And that's absolutely right. All we're going to end up doing here is just multiplying 5 times 3, 15. And what about this 4 times 2? 8. Okay, and this is all we need to do. We can't simplify that any further.
Yeah.
Simplify.
Sound good?
And to simplify, can't 8 go into 15-1, so it can be 1.
We could do a mixed fraction, but in this
But you
case
want
we're
to
not.
keep it
We want to keep it like this.
Okay.
Yeah,
Oh, okay.
excellent. Dang. Okay, Nathan, so talk to me about this next one. What are we gonna do?
Well, as far as I know, that's a whole number, that's a fraction. So you put like a denominator like 3 over 1.
Perfect.
To give it a denominator. So if we were to do the same thing as we did at the top, it would be 6 over 3, but that could be reduced.
Okay, we're gonna write this fast so we can see. You said put this over 1, right?
Yeah.
Okay, and then what did you say?
Multiply should across
Okay.
times 2 would be 6
Alright.
over 3, but that could be reduced. So it'd be 3 over 1. So it'd be 3.
2 over 1.
Oh wait, yeah.
What do you say?
2 over 1.
2 over 1?
Yeah. Yeah, I know.
Okay. Anyone else get a different answer?
Oh, I got that right.
Using 2 measurements.
Oh,
Wait, that's reduced? 6 over 3?
6 over 3 is 2. That's correct.
3,
Said it,
five.
You can also say this is 6 divided by 3, which is 2. That's not what I read. That's true. Okay. Alright, make sure you all have this method written down. This is kind of integral to what we're doing today. So just when we're multiplying, how do we multiply fractions, Brian?
We multiply fractions straight across.
Straight across. That's it. That's it. Okay. So if you want to drink your work, there's those.
So let me just say something, John.
Yes.
What I'm seeing here is that this do now would technically, they would have been able to do on their own
Yes,
to prepare for, or
Yes,
to
and this-
understand the lesson you're about to
at
teach?
this level, they should be able to do this.
But since they didn't, you felt like you should
I
just
needed to
kind of
make sure
review.
that these guys,
so you could
because
go.
in order to be, for them to be able to do what we're doing today,
Mm,
they have to know how to do this.
Yeah, good.
Yeah.
So that's called an in-flight adjustment.
Yeah, absolutely.
Good job.
I'm used to this. We do this in math all the time. Okay. Alright. Over here, Glenwood Springs, there's an earthquake that has just happened. I want you to talk with your neighbor. Let's see, the three of you can probably talk. The two of you over here. And see if you can identify how far away this is from Denver. Okay, so under the anticipatory setup of your section, the question is how far away is the earthquake from Denver? You're going to write your answer and your explanation for why. So you have about, I'll give you 60 seconds to talk to me. Okay?
Serenade me with your voice.
I don't know, they don't have a skill.
I used to live in Glenwood Springs for a little while.
Trying to find this.
So how far would you say is it from Denver?
Kilometers and miles. I think
What's
that's
that biggest?
Like in miles?
Miles up, you know?
Colorado is a really big state, so I would say about
Yeah,
200
We
miles.
have no,
100 miles.
we have no, like, legend or.
Can we do it by like measuring like the
It's shorter than.
ratings or, you know, the like, the maybe
So
shock
what
waves?
I'm hearing is that we need more information.
Yes.
Okay, so what if I tell you I measured this on a map and it's about 3 inches?
Then we need the little thing at the bottom.
Yeah.
3 inches is equal to,
Skill.
okay.
We're still missing that piece, aren't we?
Mhm.
Yeah. This is what we're talking about today. In order for us to be able to determine where earthquakes are, we have to be able to read a map in such a way that we can convert something like 3 inches into miles or kilometers or whatever it is that we're looking for. Okay. So I'm going to show you how to do this first, and then we're going to do it together, and I'm going to give you some practice that you can do. And as I'm doing this, I want you to be writing down the steps. You have a paper in front of you so you can write the steps very clearly. And I'm going to do it for you first. Now you can see what's going on here. Okay. This is an example of a scale. For example, 1 inch is the same as 250 miles. They're different in every kind of map. They're not always going to look the same, and there's 100 different ways we can write them. This is the definition that I need you to write down. A scale is a ratio of the measurements in a drawing to the actual measurements of the object. So,
That's a lie.
What's that response?
The kid said that Pluto was an actually a planet. I grew up thinking it was.
just let me get a space there for a second. Okay.
And then they said another word which I think they put that name, but.
A scale, another word for a scale is a proportion. And there's a bunch of different ways we can write it. This isn't so clear to see when I was writing it, but we can write this like 1 centimeter to a meter. Or
Yeah, like 1
1
centimeter.
centimeter to 1 meter. And that's how we're going to say this. We're going to say 1 centimeter to a meter.
Could you write 1 centimeter equals 1 meter on the
Yes, we can
scale?
also write that.
Okay.
1 centimeter equals 1 meter.
Okay,
What might be confusing about this though, Daniel? Saying that 1 centimeter equals a meter.
because it really doesn't. in
Because
the
it really
real world.
doesn't. Right. This is only true in this instance.
Okay.
Okay. And it doesn't really matter which comes first on top or bottom because this isn't a fraction. This is a proportion. This is just a way of relating the two numbers. It's a ratio. Okay. Okay. So let's take a look at this example 1. I want you guys to write this down. I'll give you access to it later. This is a scale in a diagram is 4 centimeters to 10 meters. If the distance in the diagram is 9 centimeters, find the actual distance. Okay. I have, essentially what this means is that I have a picture of a room. There's stuff in the room. But the picture's only this big, you know, it's on your page. It's what's on the paper. And what they're telling me is that for every 4 centimeters, that's the same as going 10 meters in the roof. Alright, I'll put that down.
Got it. I know it.
This is step number 1.
Maybe.
Identify what's known and what's unknown. And this is going to come directly from the problem.
We know that 4 centimeters equals 10 meters.
Yes, this is one of the things we're getting right now. Sorry. And the other thing that we know is this, the distance in the diagram is the 9 centimeters. I know this.
But we don't know how many.
I know 4 centimeters is for 10 meters. And what's the unknown? What is it, Brian? Here, that we're looking for?
How many meters actually?
What's the unknown that we're looking for?
Actual distance.
The actual distance.
The actual distance. What are the units for that?
Every 1 inch, 250 miles.
Check out this
Of
problem.
course.
In this problem, what units are we using?
CM.
Go ahead.
Oh, no, this is for Brian.
9 centimeters is. Will you repeat what you just said? What did you just say?
What? So this unknown that we're looking for,
Yeah.
what are the units of the unknown? What are we trying to solve for?
What are you trying to solve?
Read this problem to me again.
A scale in the diagram is 4 centimeters, 10 meters. If the distance of the diagram is 9 centimeters, find the actual distance.
So what is it that we're looking for?
We're looking for the actual distance.
What unit does that come in?
4 centimeters. Scale in the diagram is 4 centimeters.
Yeah, that's very good.
And 10 meters.
So what do we know?
We know the known is 4 centimeters. Well, the known is 9 centimeters.
Okay. Okay. Very good. And so what are we trying to convert that 9 centimeters into? Into meters. Does that make sense, Brian?
Yeah, that makes
Okay,
sense.
so what are we trying to convert that 9 centimeters into?
Into meters.
We're trying to convert it into meters. Very good. Okay. Step 2. Write the proportion correctly. Remember that we could write this 2 different ways. This is the same thing as saying 10 meters to 4 centimeters. What we're going to be doing, like we were doing at the beginning of class, is multiplying this fraction straight across in such a way that the units will cancel and I will be left with what I'm looking for. So I'm starting with 9 centimeters. I'm going to multiply times one of these. And what I need out is in meters. So Nathan, does the centimeters need to go on the top of the numerator or on the denominator of the fraction?
The numerator.
Okay. So you're suggesting centimeters go up here? Is there anyone that agrees? You agree?
No, wait, it's 7 bottom.
Why are you changing your mind, Nathan?
So I think a lot.
Because there's a...
There's a way more
Uh,
No, because I was thinking the aspect of like cross multiply, but that's
Oh,
not
cross
the
multiply.
case
Okay,
here.
I
So
see.
just going straight across, so it would stay on the top then.
Okay. So what are we going to do?
If you put it in the numerator, the denominator cancels out.
Yeah, that's correct. If we put the centimeters on the bottom and the meters on the top, this is essentially 9 over 1, and the centimeters are going to cancel like this. Okay, so what are the numbers that go in front here? Dan?
So it would be 10 meters over 4 centimeters.
10 meters to 4. That's right, because these are the same thing. Okay, and then what I'm going to do is multiply straight across to get 90 divided by 4. Okay. I can simplify this? Yes.
I would like to know if Nathan understands why that M is on the top now. Because I was following along with Nathan's logic and would have put it on the top.
You would put the centimeters on the top. Okay.
Well, I understand it now because like I just mentioned like the centimeters
Need to cancel.
cancel it, and I was like, okay, I remember that.
I also realized that I may have been involving too much at this point because I'm supposed to be modeling this,
Mm.
and I turned it on to them before you had even known why I was doing that. So
Good.
that's why I backed off on it because I realized, oh, he may not actually know. So sorry. This 90 over 4 I can simplify. I know at least a 2 goes into both of them. Just make 45 over 2. I don't think, yeah, that's about it. That's all I can do. Oh, and I skipped ahead, sorry, so that was step 3 was multiply and solve. Alright. So we have these 3 steps down. Identify what you know and what you don't know. What you're looking for, that way you can write this appropriately. And then write the proportion the right way so that it will cancel the units that you don't want and leave you with what you do want.
Should we get out of the fraction form so we actually know how many meters? Or should we leave it like that?
In your later math classes, and in this science class in particular, I want you to leave it like this. This is a more appropriate way of doing math. Because sometimes we'll get very weird decimals like 6.124976, like what? That's really hard to measure. And this could go on for infinity. When you say something like, oh, 49 over 2, this is shorter and easier.
So then we think into our minds that it's roughly half of 45.
Right. Roughly half of 45. Okay?
Wonderful.
Alright. Clear this off. So we're going to go ahead and do example 2 now. Get this guy written down. Okay.
Rebellion.
I see that.
Right, so it's just 3.57 meters equals.
Hold on.
Mystery.
You're going to have to be able to do this tonight and later, so if you don't have the steps written down, what if you forget?
Are we going to follow the same steps?
Yeah, we are going to follow the same procedure for this.
For this next one, I shall write it down.
Yes,
Again,
that's
it's better
good.
for you to have the steps written down that way you can remember how to do it later when you're not in class.
Steps before.
So since you've seen
Yeah,
that
sorry.
Daniel didn't do that and Sai didn't do that,
I'm going to go back
I would
to the steps. These are the steps we didn't
make
write
sure
down.
that these are written down on your paper. That's good.
Oh, right down.
These are your notes. You're gonna keep these notes, and they're gonna be useful for you when you're doing your homework. That way you can look back. Made it very clear. Your paper should look just like the board.
He did.
You did?
He did, sorry.
Sorry, it's solving.
You're doing fine. You're moving ahead too quickly. That's good. Actually, that's initiative. I really like that. But don't let initiative take away from the structure. Come on, Dan. I see what you're doing. Tell me about step 1.
Step 1 is identify what we know and we don't know.
Okay, so what do we know and do now?
We know that 2 centimeters equals 10 meters on this scale.
On the scale, very good.
And we are looking for how many meters is equal to 3.5 centimeters on this scale. That's the unknown, we don't know.
Okay, perfect, sound good. Why don't you just come to the board and write that down? Okay, Nathan, what's step number 2?
Is write proportion correctly.
Write the proportion correctly.
So,
Which way would you write this proportion?
well, how I wrote it, following the step 2 from previous problem, I had 3.5. Yeah, right.
Yeah.
I don't know if I can do that.
And that's such an emotional
I
response.
got it. Okay, let's do the code next time.
I'm not sure because I think it's proportions. Because it's not like in actuality that's 2 centimeters in real life actually equals 10 meters, but I think he's saying on like on this map or on this scale, it's proportional. So I think the semicolon is like proportion, but we're more comfortable with equal sign. So it's in this scale, just remembering this little map, 2 centimeters does equal 10, but I think that's just to denote because we're dealing in proportions on actual reality. That's not the class.
Brian, do you agree with this?
Yes, I agree with that. Because you followed the same steps, you put the 3.5 over 1. And
Okay.
you put the meter, it was the exact same step from the last.
So you guys your steps from the last.
Yeah.
Okay, so what's gonna cancel?
What is gonna cancel out is the 1. Well, the 1, I guess, you add it straight across. So that would be,
Excuse me.
you just add it straight across, right? I mean, you just multiply it straight across.
We are just multiplying straight across. Okay, so what if I multiply straight across? Talk me through this, Brian.
Okay, 3.5 times 10
Okay, what is that?
would be 30, 35.
35?
Yeah.
Okay, what are the units?
The units,
Centimeters.
the meters,
It's a centimeter times a meter. So I'm just gonna write a centimeter times a meter.
centimeter times a meter.
That's what we did, we multiplied a centimeter times a meter. Okay, you're doing fine. You're doing fine, don't panic. Talk to me about the bottom.
1 times 2, which is 2
Okay, and then what are the units?
centimeters.
Centimeters. What's gonna cancel over here?
I don't know what's gonna cancel.
Is that what's gonna cancel?
So the centimeter divided by centimeter cancels out.
Did you see that, Brian?
Okay,
So what's gonna cancel, Brian?
centimeters gonna cancel.
Centimeters gonna cancel. So what are the units that we're left with?
Meters.
The meters.
Right.
Is that what we're looking for?
Yes.
Okay, now step 3 as well. It's just to multiply and solve. So what is our final solution then?
35 over 2.
35 over 2. Is that the appropriate way to leave that?
Yes, it's the most accurate.
It's the most,
That's there.
it's the most accurate way of saying it. Very good. Alright, so there's that. So on the next page, on the handout that I've given you, you have a worksheet. I want you to ignore everything that's on it. I'm just kidding. On the bottom 4, there are 4 questions at the bottom. I want you to work with your neighbors and solve those. On the 3rd page, this is where I want you to do your work. You're going to keep this sheet, but you're going to turn in the 3rd page back to me. Okay?
So the full problem.
Yes, so you're going to do it. Let's go about right there.
Do we want to split the problem? Do we want to split the problems up, or do we want to do? Is I already doing them? Oh my goodness, it's jumping ahead.
Well, if I could just say, technically, what should John make sure you do right now, Daniel, to answer your question?
Well, we should probably do an independent guided practice.
Which one?
Guided?
I would say guided. So,
Because-
which would mean the 3 of you work on them together.
Okay, yes.
You
And
got
then,
it.
That was the
and
intent.
the second one we do, yes.
Mhm.
I'm just rebelling, I'm sorry.
That was the intent.
Yeah,
Okay,
which I'm sure, you just circulate, but obviously they're.
so I think we're
It's easier
ignoring
than
the
I'm here to
top
screw
part of
this
the
up when I say,
bottom.
no.
Bottom 4, so the word problem,
Yes.
the word problem.
The
Oh, wait, how much have that to say? Okay, so I'm just gonna ignore the words and just look at the numbers, because this is what we do. So it's, and I like what you said, Brian, I'm not gonna worry about proportion, I'm just gonna use equal signs, because that's what I'm kind of more used to. So 5.5 centimeters equals 1 kilometer, right?
Right?
Yeah.
The straight distance between 2 huts on the trail is 16.97 meters, but we don't know how many meters that equals. So I guess we're looking for the meters again. Does that make sense?
Is it?
Alright.
So you're doing.
Because it's kilometers now.
She's looking at.
Number one.
Oh, you're doing.
Or Fiji, where I was looking for glasses. I guess meters, kilometers, we're looking
So we are
for
doing
some
number
meters.
one.
Yeah, you're doing the right steps. Everything you're
Okay.
doing is right.
So 0.5.
So 16.97 meters equals, we don't know how many kilometers, that's what we're looking for. Like this is like the
That's the
goal.
first step.
Yes.
But
I like that you went
First
online.
step, check. So, here, Harvey wants to transfer this information over here, so I'm not confused.
9, 7,
Top of the page.
Yeah, let's-
To the back end.
It's on the next page. Right.
5.5 centimeter
Okay.
to
so what I'm going to do
1 kilometer. It's the same, 1
is I am going to, because we want kind of the centimeters to count, so I'll have to be left with kilometers, right?
Yes.
Alright, so I think the way we need to write this is,
Well, hold on, this should have been.
Am I wrong?
Where's the map though? Make sure you keep the units as well.
Very.
Make sure if you write the units down.
it keeps us to keep track. Just because we're looking 1 kilometer, it's not.
Yeah, so that's centimeters.
And you have
Okay, so what's the number there?
We got it right.
0.5.
So right off the
Yeah.
top.
Let's move on to the next.
So you want
This is.
Half.
that's the.
I'm gonna divide by half.
Do you want to switch it around so that you can have some?
This one, what you did was so the.
Divided by 2, because
Here,
you're,
let me picture one more. So we have, you're doing 16.9,
yeah,
and you're dividing it by 5.
yes.
This is the same thing as a half.
Yeah.
So 16.9 divided by
And
half.
straight across?
Yes. Okay.
So, this,
So 2 over 1.
yeah, this is 16.9.
It stays the same, sort of.
So then we do 16.9 times 2. And then,
Okay, thank you. Yeah, dividing by half is just.
good to know. I'll write that rule down forever.
On the top.
It stays the same.
Yeah, that's up there.
That's,
So this is CM and
So,
It's taking longer than I thought.
yeah,
That's why we.
good. So let's, what would you do after this then? They do some individual problem?
Yeah, just the one back from earlier. With the,
So if-
As like a,
yeah, it's just a,
like a closure?
Yeah.
3, 3, 3.
Well, let's have them do that then,
okay,
and then finish up. Then good.
alright. So let's just gonna move ahead. This is where we're learning this skill.
Calculator?
Yeah. This is why we're learning this skill so that we can look at something like this to figure out how far the earthquake is. So now given this new information, take this problem from before and write down at the bottom where it says exit ticket. I want you to work this up. And identify by yourselves, we're not working together, how far away this earthquake in Glenwood Spring is from Denver. Okay?
It's for
Now
this.
we have
Scale of users.
That's.
We're using that scale.
it's on the bottom.
Shit, that'd be just like
So we're looking for
30
miles.
inches, 30 miles.
Exactly.
Okay.
This is not too complicated. We're not supposed to be working together.
Oh.
Just make sure you have the steps written out. I want to see your thinking down here in the bottom. Yes.
And so,
Yes. I want to see clearly what's happening. Perfect. That's it. That's the one. You can turn that in. You're free to go.
yeah.
I'm just kidding. You have to wait for the bell.
I don't make the note that.
Can you check mine?
You come. That's very good.
I'm sure it's just adequate.
Whoa.
Okay, so
Okay.
what, just wrap it up.
Is this our expect ticket?
Okay.
You right, we give this to you?
I want you to hold on to these notes. You're going to
Okay.
turn in this last page to me. And use these notes again when you're going over some of your homework problems that you've already got assigned. And then I'll see you guys tomorrow. You're free to go.